Welcome to a new series where we find serious answers to funny questions. Here I am back with another funny question. Have you ever thought how many fireflies would be needed to equal the brightness of the sun? It is crazy, I know, but what is life without a little bit of fun? Well, it would take a substantial number of fireflies, definitely a figure with many zeros, but in the grand scheme it's not as astronomically large as you might think. Fireflies may appear to be filled with glowing substance, but their light actually originates from a thin layer on their surface. Many insects possess luminous patches on their bodies, and studies on beetles referred to as headlight bugs in a 1928 paper revealed that these patches, slightly larger than 1 square millimeter, emit approximately 0.0006 lumens of light. Fireflies have luminous organs of similar size to these beetles, and their organs exhibit comparable peak brightness per unit area, making this estimate a reasonable approximation for the brightness of a firefly's lantern. The sun's brightness is approximately 3.8 x 10 circumflex 26 lumens. Adult fireflies weigh about 20 milligrams, which means it would take 3.1031 of those fireflies to emit the same amount of light. They would only weigh about a third as much as Jupiter and 1/3000th as much as the sun. In terms of brightness per pound, fireflies outshine the sun. Despite bioluminescence being far less efficient than the sun's fusion-powered light, the sun's longevity requires it to emit less intensely over time, because the sun can't afford to be as bright as it needs to last billions of times longer. But wait! A mass of fireflies that big would run into problems. Besides logistical issues of collecting so many insects in one place, the fireflies would block each other's light. The inner fireflies would be hidden behind the outer ones, and the total brightness would get affected. If we focus only on the light emitted from the surface, we could envision arranging the fireflies in a hollow sphere with their lanterns facing outward. To match the light output of a normal firefly, our hypothetical firefly would need to be 3 by 10 pi-31 times larger in terms of glowing surface area. Since surface area scales with the square of the length, this means the firefly would need to be 3 by 10, 31 equal sign 5 by 10 15 times longer than a typical firefly. In practical terms, this would make the firefly roughly the size of the solar system. Such an enormous firefly would quickly collapse under its own gravity and become a black hole almost immediately. Given the distribution of galaxies in our universe, there's a maximum size for black holes, and our firefly would surpass this limit, becoming the largest black hole ever known. At first it would shine brightly as it devoured our galaxy, but over time it would stop emitting light entirely. Given that our firefly's black hole would be the universe's largest, a unique anomaly in a universe winding down towards heat death, it would be the final one to evaporate. Would you like to experience something like this in this life? If you want answers to more such life-altering questions, then like, comment, and subscribe to this channel.